Hello there. In this video, we're going to be starting down a journey to read the hopefully entirety of the Rust programming language book. This is kind of the canonical book that you should read if you are trying to learn Rust. At least so I've been told, and so I believe from what I've read of it so far. And I just figured I, at this point, do plan to finish reading the book and might as well, having put the book aside for some time, go back to the beginning and read it. But what I had read so far was quite informative and helpful for me in understanding what I've understood about Rust so far. So I figured I might as well vlog this experience, and if you're interested in going on this journey with me, then welcome, and we'll go through it all together. And where there's code, I will run, I think many, maybe not all, but many of the code examples, just so that we can see firsthand what it looks like, maybe learn about some of the problems as we come about it together. Okay, great. So the very beginning, the Rust programming language. This is written by Steve Klabnik, Carol Nichols, and Chris Kryko, I believe, or Krycho, forgive me on the pronunciation, with contributions from the Rust community. So the version of the text assumes you're using Rust version 1.85.0, which was released on 2025, February 17th, or later with edition 2024. In the cargo toml file for all projects to configure them to use Rust 2024 edition idioms. I'm just going to turn off the vibration notifications on my phone. Leave that alone. All right, the HTML format is available at this URL, which we're probably not going to look at right now, and offline installations of Rust made with rustup, run rustup doc book to open. Okay, I don't think we're going to do that either. I think the web interface here is fine. There's also different translations into different languages. At this point, I don't think I would usefully be able to read it in another language, so we're going to stick with English. So this text is available in paperback and ebook format from the No Starch Press. And they have a final point, and I'm intrigued and would like to explore this more in the future, but I think I'm going to stick with the canonical book that we've got in front of us. But they also mentioned that they've got this interactive version of the Rust book. How that's different from Rustlings, I'm not sure at the moment, but we're going to leave that to the side for now. So that's their opening page for the Rust programming language. I mean, there's nothing on this front page that kind of introduces us to Rust yet, but it's just the preamble of, or the preface of saying, it's really a preamble of just going like, this is what you should broadly know as the most basic information about what's assumed to read the book. That's fine. So now we're on to the foreword, where hopefully they give us an invitation of sorts to read the book. So, foreword. It wasn't always clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you are writing now, Rust empowers you to reach farther, to program with confidence in a wider variety of domains than you did before. I don't know if that's true. I feel like it is true for me that if I learn lots of Rust, that I should be able to do more systems programming type stuff. But for a lot of the stuff that I want to use Rust for is mostly to implement specific algorithms much faster than the implementations would result when I write them in, say, Python. So I think it's technically true, but I don't know that this is true for everyone. I can readily imagine somebody learning Rust and going, yeah, like this is great, but I can also do these things in other ways. Oh, and anyway, so take, for example, systems level work that deals with low-level details of memory management, data representation, and concurrency. So memory management is about your computer has to allocate a certain amount of space to work with data in a more timely fashion. The data representation part is kind of interesting. I don't know if they're just saying data structures there, or if they're talking about how data structures are laid out in memory. I'm not sure. And then concurrency, which is the whole topic of what if things are running in such a way that you can have potentially overlap, but it's not just about parallelism. It's like there's no control over when things are happening, strictly speaking. Traditionally, this realm of programming is seen as arcane, accessible only to a few who have devoted the necessary years learning to avoid its infamous pitfalls. And even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. I mean, some of those topics are pretty niche, like getting into the details of memory management as a Python programmer. I just let the garbage collector do its thing and I don't have to think about it all that much. So I'm kind of excited to deal with memory management a bit more with Rust. But of course, I think some of the idea with Rust is with its borrowing and lifetime mechanisms that it's going to put some automated controls at a compiling level, which is also going to be very interesting. Okay, so yeah, I mean, and then I don't know, data representation. I think about how to structure data all the time as a data scientist, but concurrency, yeah, I only do a little bit of this, and I usually only do the easiest forms of saying I have to do this blah 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 thing 10,000 times, and just split into a bunch of parallel processes, as many CPU threads as I have, and just work through them in parallel. But usually that's the easiest case of concurrency, or one of the easier cases anyway. I think the trickier cases get into when you have like shared memory objects and you've got different processes on your machine or across multiple machines that want to access some shared memory resource. I think that gets trickier, and I'm curious to see if this book talks about that. And if not, I know there are Rust books on concurrency that I can read later. Okay, so Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to dip down into low-level control can do so with Rust, that's what I'm looking forward to, without taking on the customary risk of crashes and security holes, and without having to learn the fine points of a fickle tool chain. I think that's kind of a complaint about Make or Auto Tools or something, but yeah, if you're coming from C has kind of got a different history where a lot of the tools evolved over a long period of time, where my understanding with Cargo is it just comes with a bunch of stuff ready for us to use out of the box. You want formatting, you got it. You got linting, you got it. You got like a checker to just for syntactic correctness without full compilation, you got it. Or you want to like immediately run after compile, Cargo run. My understanding is that the tool chain for Cargo is very nice. And also handling like, crates are what they're called, or what in Python we call like packages. I'm excited for that. A lot of the stuff I work with is not really like open to the World Wide Web, and so I'm not that concerned about security holes, but that's good to know. Better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. Now, that is very appealing to me because one thing that, dynamically typed languages with garbage collection are not is like highly efficient at runtime. Okay, so programmers who are already working with low-level code can use Rust to raise their ambitions. Sure, all right. For example, introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch the classic mistakes for you. I think with Python, my experience is that I don't really run into issues, but it's good to know that Rust is also going to cover our butts. And you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerabilities. I mean, you can still make like runtime crashes with Rust, I think. Like it's not like you can't have unusual bugs. But anyway, okay, but Rust isn't limited to low-level systems programming. It's expressive and ergonomic enough to make command line interface apps, web servers, and many other kinds of code quite pleasant to write. You'll find simple examples of both later in the book. Okay, nice. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. So I think this is a general win for general purpose programming languages that really you could do almost anything. And most programming languages, frankly, are like really general in the sense that you learn how to write programs in one area, and it will probably help you write programs in another area. But still, it's not wrong. It's just a good point to mention this is not like Rust-specific benefits here. This book fully embraces the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to learn, and welcome to the Rust community. That's from Nicholas Matsakis, I think. Matsakis, maybe, and Aaron Turin. Great. So, introduction. They mentioned again the Rust book is actually available in print, and that there's, I guess it's in an ebook format also from No Starch Press. Okay, so welcome to the Rust Programming Language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. At least I think that can be true, depending on what you're coming from. For me, that will probably be true. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict. Through balancing powerful technical capacity and a greater developer experience, Rust gives you the option to control low-level details such as memory usage without all the hassle traditionally associated with such control. Okay. I mean, like I've heard people like Primeagen online make a more nuanced take about the pros and cons of Rust, but yeah, like this sounds good to me. Who Rust is for. Rust is ideal for many people for a variety of reasons. Let's look at a few of the most important groups. So, teams of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of systems programming knowledge. Okay, no citation. Do they give an example? Low-level code is prone to various subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. Seems like we moved on. In Rust, the compiler plays a gatekeeper role for refusing to compile code with these elusive bugs, including concurrency bugs. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. I mean, I think that these are things that could be true. I don't know that they're always universally true, but, you know, it is appealing to me coming from Python to have an option for a lower level programming language that still in the background is going to make sure that I write memory safe or memory correct code, at least as much as can be caught by the compiler. It is appealing. Okay, Rust also brings contemporary developer tools to the systems programming world. So Cargo, including the dependency manager, which I think is great, build tool, makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. So I've played around a bit with Rust and Cargo in particular, and I find that Cargo is actually quite nice, including for the whole package management, dependency management part, and it's easy to update the dependencies and to customize them with those TOML files. It's actually a pretty easy time. The Rust formatting tool, Rust Format tool, ensures a consistent coding style across developers, which I think is pretty good. I mean, style's not the end-all be-all, but I think there is something psychological about reading code that's like really, really different. It does get distracting, so might be good. The Rust Analyzer powers integrated development environment IDE integration for completion and inline error messages. Yeah, I use this with NeoVim actually, and it's pretty nice. I'm sure we'll look at examples that show that. By using these and other tools in the Rust ecosystem, developers can be productive while writing systems level code. Awesome. Ooh, students. That's not technically me. I'm not a student at a university or anything like that at this stage, but basically I look at myself as a student of Rust at the moment. But what do they actually say? Rust is for students and those who are interested in learning about systems concepts. Yeah, I think I want to know a bit more. Using Rust, many people have learned about topics like operating systems development. Cool. The community is very welcoming and happy to answer questions. You know, I don't know that yet, but I mean, I see lots of examples of it on Reddit, and there's also a Rust discourse that you can check out where, yeah, there's like a lot of Q&A, and I'd say that stuff looked pretty reasonable and level-headed. The discussions there, the question and answers and stuff was good. Okay, through efforts such as this book, the Rust team wants to make systems concepts more accessible to more people, especially those new to programming. So, next group of people, companies. Hundreds of companies, large and small, use Rust in production for a variety of tasks, including command line tools, web services, DevOps tooling, embedded devices, audio and video analysis and transcoding, cryptocurrencies, bioinformatics. I used to do some bioinformatics actually when I worked in ecotoxicology, so I can definitely see why there's actually a lot of algorithms in bioinformatics that it's good to have it in a statically compiled language and not garbage collected, because the performance requirements of bioinformatics gets very heavy for things like multiple sequence alignments and clustering DNA sequences and stuff like that. It can be a lot. Search engines, sure. Internet of Things applications, machine learning. So I don't actually see a lot of people doing machine learning in Rust, but there are some crates that I saw are out there. Maybe we'll try some crates at some point for machine learning. But by and large, a lot of the data science that I do is based on Python, that is presumably calling stuff that eventually boils down to bindings to C and maybe some C++ and occasionally Rust. I know some of it's Rust, but a lot of it is still C and C++. Okay, open source. Oh, and then I forgot the last bit of that sentence. Even major parts of the Firefox web browser, apparently. Okay, I mean, I'm fine with that. Okay, open source developers. Rust is for people who want to build the Rust programming language, community, developer tools, and libraries. We'd love to have you contribute to the Rust language. So this might eventually be something that I can contribute to a little bit, is libraries. Like, I don't mind building stuff. And I did write a cargo Desra, which is one of the reasons why I want to keep going through the Rust book, is because I started writing this crate for doing discrete event simulation in Rust, mostly as a learning experience, but who knows, maybe it'll be more usable in the future. And so I did learn some Rust before reading this book, or before making this video series reading the book. But I only got so far, and then I was kind of like, I kind of maxed out on going, you know what, I need to spend more time learning Rust itself, because trying to intuitively grok your way through a programming language, especially one that's substantially different from what you're used to, you can try it and see how far you get. Oops, calculator. Yeah, anyway, libraries might be eventually a thing I write more of. People who value speed and stability. Rust is for people who crave speed. What a weird thing to, okay. And stability in a language. I don't know, crave's interesting word, but yeah, okay. I mean, it is something that I value. I want to be able to write some code that I have a lot of confidence that it's correct and that it's substantially faster than the stuff that I can write in Python. And for me, this intersection of like what, or extension going into Rust has partly to do with, I don't think that even the language extension tools for Python without being able to write in another language are super great. You could still say, why not C or C++, but I think that it's a good idea in the long run, if you want to be able to write really performant implementations, is to be able to write it in something that's not Python. And I know there's Python. I looked at that. Maybe we'll talk another occasion on why I think it's time to bite the bullet of like why Rust. But for now, we're just going to keep on with this topic of just exploring who is this for, really, overall. Great. So by speed, we mean both how quickly Rust code can run and the speed at which Rust lets you write programs. The Rust compiler's checks ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. Maybe at some point I'll talk more about, working with legacy code is a great book, and also Fowler's, so Michael Feathers, I think it is, working with legacy code, and Martin Fowler's book on refactoring, but stories for another time. But like, you can do practices in any language to help improve that situation of dealing with brittle legacy code. So anyway, by striving for zero cost abstractions, higher level features that compile to lower level code as fast as code written manually, Rust endeavors to make safe code be fast code as well. So I think that compared to, in my opinion, or at least my rough understanding of some of the other languages that are out there that are low level, is that you do have to do some of the manual control of memory, and that there are mistakes, which are, from what I've heard, not super hard mistakes to fix, but nonetheless, the idea, some of the appeal of Rust is that it just makes some of those mistakes impossible to do while letting the compiler actually accept the code in any sense. Okay, the Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed and ergonomics. Give Rust a try and see if it works for you. So I have tried Rust, and so far I really like it, and I mostly agree. I think that the idea that you can eliminate all the trade-offs is not a reasonable thing. But, maybe a lot of progress will be made in the future. Maybe it is possible to eliminate all the trade-offs, but I don't think that that's possible right now. Still, it doesn't mean that it hasn't alleviated some of the problems, and so, that's where some of the appeal of Rust comes in, I think. Who is this book for? This book assumes you've written code in another programming language, but doesn't make any assumptions about which one. Okay, we've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to programming, you would be better served by reading a book that specifically provides an introduction to programming. That's fair enough. I mean, if you've written in most programming languages, the idea of a function is going to be just bread and butter. Declaring variables, if-else blocks, all that kind of stuff shouldn't really be a surprise, in that it's mostly a matter of the finer points of the syntax being different, rather than like seeing something that's conceptually new. Okay, how to use this book. In general, this book assumes that you're reading it in sequence from front to back. Noted. We're going to try to do the same. Later chapters build on concepts in earlier chapters, and earlier chapters might not delve into details on a particular topic, but will revisit the topic in a later chapter. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you'll learn about an aspect of Rust. In project chapters, we'll build small programs together, applying what you've learned so far. Chapter 2, 12 and 21 are project chapters. The rest are concept chapters. Okay, fair. Chapter 1 explains how to install Rust, how to write a Hello World program, and how to use Cargo, Rust's package manager and build tool. Chapter 2 is a hands-on introduction to writing a program in Rust, having you build up a number guessing game. I actually think I did cover that on my own time once, but we're going to do it again together. Why not? Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. Chapter 3 covers Rust features that are similar to those of other programming languages, and in Chapter 4 you'll learn about Rust's ownership system. I'm actually looking forward to that because while I did read a bit about it, I still think that I should review it again, because I think you can, pun intended, get a bit rusty at it if you don't write Rust on a regular basis. And I have taken a bit of a break myself. So, if you're a particularly meticulous learner who prefers to learn every detail before moving on to the next, you might want to skip Chapter 2 and go straight to Chapter 3, returning to Chapter 2 when you'd like to work on a project applying the details you've learned. Now, I think we will do this in the most linear sequence so that I don't have to think about what chapter or section of a chapter we've covered or not covered. It should just eventually be a sequence of videos that we can refer back to. Okay. Where was I just reading? You'd like to work on a project chapter that you... Yeah. Okay, so Chapter 5 discusses structs and methods. I think I've done that stuff myself. Chapter 6 covers enums, match expressions, and if-let control flow constructs. You'll use... Oh, that's right. I think where I got to when I was doing this on my own is I think I got up to traits, but didn't really like master traits. So traits are super cool because you can attach different functionality to different data structures. It's like having a lot of the benefits of object-oriented programming, but without inheritance. It's actually pretty cool. Okay, in Chapter 7, you'll learn about Rust's module system and about privacy rules for organizing your code in its public. That's going to be a good one for me because I have questions about how to best organize a Rust library, including like where should I put the test module? Should it be in the same RS file as the implementation, or really should it go in like a different directory with a tree structure that matches the tree structure? of the source, of the main source. I don't know. There could be some trade-offs there, and I'm curious about what the typical way to do that is. All right. Privacy rules, public programming, and its public application programming interface API. Sure. Chapter 8 discusses some common collection data structures and that the standard library provides, such as vectors, strings, and hash maps. Chapter 9 explores Rust's error handling philosophy and techniques. Chapter 9 digs into generics and traits and lifetimes, which give you the power to define code that applies to multiple types. That's pretty exciting to me. A combination of generics and traits are probably what I need to do, and enums are what I need to do to update my discrete event simulation library. Make it a bit more generalizable without having weird things of having to pack metadata into strings and then parse them out again is kind of a weird way to do it, but that's currently how it does it. Okay, Chapter 11 is all about testing. Nice. Which even with Rust's safety guarantees is necessary to ensure your program's logic is correct. 100% agree. I mean, you can still write the wrong program for the right problem. You can also write the wrong program for the wrong problem. But, anyway, yeah, absolutely. Correctness of syntax does not guarantee, and correctness of like memory safety does not guarantee that you've got a program that does the stuff that you actually need and want it to do. Chapter 11 is all about testing. Oh, I just read that. My goodness. In Chapter 12, we'll build our own implementation of a subset of functionality from the grep command line tool that searches for text within files. I love grep. I've been using it for ages now. What a great tool for searching the contents of files. So for this, we'll use many of the concepts we discussed in the previous chapters. Okay. Chapter 13 explores closures and iterators. I've used a little bit of both, but I can't say that I've mastered them myself. Features of Rust that come from functional programming languages, sure. So with Python, it's not that unusual to create like Lambda functions that are passed into some arguments for dependency injection. And I think you can use closures in a similar way. At least that's what I tried to do with the with Desra, the discrete event simulation Rust library. Okay. Every time I'm going to stop and talk, and then I have to go find out where I was again. It's just hilariously, it's a challenge for me. Okay. So in Chapter 14, we'll examine cargo in more depth and talk about best practices for sharing your libraries with others. I probably should have read that before sharing a library, but I did it. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable their functionality. That's also going to be interesting because with Python, you can kind of just assume that you're just declaring variables and you don't have to think about how there's a relationship between pointers to data, like pointers that exist on the stack and how they point to things on the heap, and like there's different types of pointers. It's just not a thing that you think about in typical Python programming. And maybe not even Python programming at all. Okay, Chapter 16. We'll walk through different models of concurrent programming and talk about how Rust helps you to program in multiple threads fearlessly. I've heard this phrase of like fearless concurrency. Okay, we'll find out what that is. In Chapter 17, we build on that by exploring Rust's async and await syntax, along with tasks, futures, and streams, and the lightweight concurrency model that they enable. Chapter 18 looks at how Rust idioms compare to object-oriented programming principles you might be familiar with. Chapter 19 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. That sounds pretty great. Chapter 20 contains a smorgasbord of advanced topics of interest, including unsafe Rust, macros, and more about lifetimes, traits, types. Ooh, yeah, right, types. I forgot. Types, pretty interesting. Functions and closures. Types are like another abstraction that connects on top of the layer of traits, if I remember that right. That's going to be interesting. I think a lot of flexibility might come out of that. And also opportunities to shoot yourself in the foot. Okay, in Chapter 21, we'll complete a project in which we'll implement a low-level multi-threaded web server. I guess that's pretty cool. I actually currently don't do a lot of creating web servers, but I can see why this, in the current day and age is appealing as a project. But who knows? Maybe someday I'll use that. Maybe I'll serve like a dashboard or something using a web server. That'd be cool. Okay, finally, some appendices contain useful information about the language in a more reference-like format. Appendix A covers Rust's keywords. Appendix B covers Rust's operators and symbols. Appendix C covers derivable traits provided by the standard library. Like, we're probably going to cover that debug trait for letting things be easily printable. Appendix D covers some useful development tools. Appendix E explains Rust's editions. That was mentioned before, that this book assumes Rust edition 2024, and they're not like an every year thing, if I remember. Only certain years they release an edition, and it's like a super version on top of the semantic versioning 2.0 standard of going, there's also these bigger releases of Rust that come out. In Appendix F, you can find translations of the book. Okay, I probably might skip that. I don't need to read the same documentation in many languages. And in Appendix G, we'll cover how Rust is made and what nightly Rust is. My understanding of nightly Rust, I could be totally wrong, just going to spitball here, is that it's like the very freshest features that have been added, but presumably either less constraints on the amount of time have gone by, that it's like the latest stuff that might break, combined with, I don't know, maybe there's a fuller process of like software quality assurance, and that maybe the nightly stuff is not quite the same. This is just speculation. I don't know that it's the case, but it's like the most raw, fresh things that have been less tested might be what nightly Rust is. Okay, there is no wrong way to read this book. That's probably false. You can always mess something up. All right. Fair enough, though. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience any confusion, but do whatever works for you. Now, that last part, I strongly endorse that in general. Do whatever works for you. You know, and I'm mostly going through the book in some linear order because it helps me keep track of what I've covered, to go, this is like a loading bar, and I just need to read from top to bottom, as it were. But, you know, if I was just trying to understand a specific thing and I was using the Rust book as a reference to understand that thing, absolutely, I don't need to go read the entirety of the book up to like the section on traits to go, right, I need to freshen up on traits, right? That's fine. Okay, an important part of the process of learning Rust is learning how to read the error messages the compiler displays. You know, that's a huge thing with Python as well, and I'm sure it's a very general programming piece of advice, which is to learn the messages that are actually displayed, because some messages will actually be very, very helpful for you up front of just telling you what the problem is, and Rust errors I've found so far are really good for this. But I remember even with Python tracebacks, even the ones that are kind of obscure, they're statistically related to certain kinds of problems, and that helps you as a programmer guess where to look for the problem or where to set a debugger breakpoint and stuff like that. So you know what? Like, it's great advice to read the messages and try to understand them. These will guide you towards working code. 100% agree. As such, we'll provide many examples that don't compile, along with the error message the compiler will show you in each situation. Know that you enter and run a random example. Know that if you enter and run a random example, it may not compile. Okay, fair. Make sure you read the surrounding text to see whether the example you're trying to run is meant to error. Ferris will also help you distinguish code that isn't meant to work. Ooh, it's Ferris. I guess that's the name of this little Rust mascot. Ferris. I feel like there's got to be a joke, especially intersecting with Python. Like, how do we make this? It's like the term that's coming to mind is like a Ferris wheel. And maybe if I was like writing a Rust extension for Python using something like the Maturin build system, and I'm using like the Pio3 FFI or one of the other foreign function interfaces, to just be like, I build a wheel, and it's like, oh, it's a Ferris wheel because it's got Rust in it. Is it all that funny? No, it's not, but I'm trying. Okay, so anyway, Ferris with a question mark means this code does not compile. exasperated Ferris with his little claws sticking out to the side. This code panics, which is the term for basically like just crashes or exits the program immediately or whatever. And then a little claw off to the side, but no question mark or anything like that. This code does not produce the desired behavior. So maybe it does compile, but it's not correct. Okay, in most situations, we'll lead you to the correct version of any code that doesn't compile. And then a final point about source code. The source files from which this book is generated can be found on GitHub. All right, good to know. So that's our first jump into reading out of the Rust book. That's probably about as much audible kind of reading as I can do for the moment. I need to go drink some water and whatever. But hey, hopefully you got some value out of watching this first piece and seeing me make some comments out of what I'm reading. Personally, this is always the most boring part of a book to me, like the stuff that's just the high-level preamble. Like, let's hear what the organization of the book is. And that it's more when I need to use the book later as reference that understanding the structure of the book is more valuable. I want to read this book from start to finish. It doesn't matter what chapters are for what. You're going to cover it in some order, and hopefully the linear ordering is sensible. So, anyway, that's that for this video. I hope you have a good day, and I'll catch you in the next video. Take care. Bye-bye.